Hello, this is Dr. Mears, and today we are going to be learning about inverse linear functions in our course Applications and Interpretations, SL1. First, a one-to-one function. A one-to-one function is a function where one value of x will have one and only one value of y. So one arrow to the y's from the x's. Okay, and this is the one-to-one part. And one value of y will only have one and only one value to x. So one-to-one function, anytime I put the number 1 in, I'm always going to get the number 2 out. Anytime I put the number 2 in, I'm always going to get the number 4 out. Always. I'm not going to get a different number ever. And I'm going to write that down. Every time I put a 1 in, I will always get a 2 out. So this will always happen, and so on. For all those numbers. Okay, let's look at an example of not a one-to-one function. So for this one, this is a function. Okay, it's okay that they have the same output. However, these are mapped to the number 3. This does not have an individual one. So the 2 goes to the 3 and the 4 goes to the 3. You cannot have that because the 3 can only be mapped to 1. So because there's 2 arrows there, not one-to-one. So it is a function, but not one-to-one. You can't have double arrows. Okay, let's look at a graph. What will that look like at a graph? Okay, well, remember the vertical line test? So the vertical line test said I can take a vertical line and I can scan it across my picture. And anywhere I stop, vertical line, my pencil or my vertical line will only touch that graph once. So it only touches there. Let's say I stopped here, only touches there. So this passes the vertical line test. Now, so vertical line is up and down. Horizontal line test is going from the bottom to the top. So again, anywhere I stop, I'm only going to be touching this line once. I don't care where it stops, but I can only touch the graph once. That's the horizontal and vertical line test, and it's one-to-one if it passes both. Then it's going to be one-to-one. Okay. Let's look at a graph that's not one-to-one. Okay, that does not pass the vertical line test or the horizontal. So let's look. So horizontal goes vertical. Let's look at the vertical first. We're looking vertical first. So vertical goes this way, okay? So anywhere I stop, I am only going to be touching this graph once, anywhere. So check on the vertical line test. How about horizontal line test? So now I'm going to bring my pen and my pencil and I'm going to scan it from bottom to top. And when I do, let's say that I stopped here. Guess how many times it crosses? 2 times. And we cannot have that. So this is not one-to-one because the horizontal line. So it did not pass the horizontal line because it touched here and here. We can't have it touching twice, only once. Okay, why are we learning about these inverse why are we learning about these one-to-one? And that's because we're going to be learning about inverses. Inverse function is a function that is one-to-one. So every one-to-one function has an inverse. What does that mean? The inverse reverses the action of the function. Remember, we know inverses. What's the inverse of multiplication? Division. What's the inverse of addition? Subtraction. What's the inverse of squaring a number? Taking the square root of that number. So we have all of these. Inverses just undoes the actual action. It reverses it. All right, well, what does that mean for our inputs and outputs? First, here's the original function, f of x. When you see this little -1 here, as that in that exponent spot, this is referring to its inverse. Basically, we switch the x and the y. That's what we do, okay? So let's look at this function here. Here is my x, here is my y. So let's put this in an ordered pair. So we have my x is a. Who is it going to? Let's follow the arrow. That's 3. Okay. My b, follow the arrow, goes to 1. So I'm just writing this in ordered pair to show you. What's next? C. Who does that go to? 2. So this is 1 to 1. We have one arrow here. We have one arrow here. It is 1 to 1. So this is the original function, f of x. What happens when we take the inverse of that original function? So let's look. This is our inverse here. So f inverse of -1 of x. What happens? All right, well, let's write the 1 down. Who does that map to? B. Oh, look. Originally, it was B1. What happens? Now they got flipped. They really just exchanged places. So we have 2, C. Well, let's look up here. Oh, look, originally it was C2. What happened? It got flipped. Okay, and the last one, 3, who does that get mapped to? A. Let's look, A3. So it got flipped. So all you do is you just interchange the x and the y. That's it. Okay. All right, how do we use this with our examples? Here's the graph that shows the function of f. All right, we have our x, we have our y. Let's see what we count by here. So let's see our scale. So this goes 2, 4, 6. So these little lines in the middle, we're counting. This is 1, 2, this is 3, 4, and this is 5, 6. So we're counting by ones here. Same thing, 2, 4, 6. Yeah, so this line here is 1, this is 3. I'm just putting the numbers in. This might help us later. I liked using numbers. Okay, so I just filled my numbers in. You can do the same for the negative if you want. All right, what do we have to do? Use the graph to find f of 2. Now remember, this is f of x, and that's going to give us the y. So what they want us to do here is they want us to go to the x and go to 2. So here's the x. We're going to go to 2. We're going to go all the way up, and we're going to see what our y value is. Good thing I put those numbers in. So I went to 2. Once I hit the line, because this is what we're talking about, this line right here, I'm going to go over. I'm going to find the y is 5. So that's it. Okay, we've done that before. Well, let's look at inverse. The inverse. So when we have the inverse, what happens is this is now the y. So the 9 is the y, and they want us to find the x. So we're going backwards. So we're going to go to the y. We're going to look for 9. Here's the 9. We're going to do the same type of thing. Go to the line, but this time we're going to find that the x is 4. So we went backwards. We went to the y. We had to find the x. We went to the y. We had to find the x. Okay. Solve the equation inverse of a equals 1. So what is this? F of -1. Since that little -1 is there, this is going to be my y value, which we don't know yet. That's what we got to find. They want us to find a. We have no idea what a equals, okay? But we know that the x is 1. So if you see this little inverse, that means the y is now here, and that equals the x. So we have to go to the x-axis and go to 1. So let's go to the x-axis and go to 1. We're going to go all the way up. We hit the line. So let's see what our y value is. Our y value is 3. So a equals 3. What that means is if I went to the 3 on the y, I would get out an x of 1. Notice this is reversed. than what we had before. So if you understand that we're just switching X and Y, and if you understand how, going to the X and looking for Y, or going to the Y and looking for X, reading the graph both ways, then you really are going to start to understand inverses, because we are going to be getting into more inverses in the future. This has been Dr. Mears. Hope it helped.